So in this video, we talk about memory instruction set architecture (ISA). So we know that a computer instruction set architecture (ISA) specifies the format of its instruction and the primitive operation that a machine can perform. So the ISA is just an interface between a computer hardware and its software. Some ISA include hundreds of different instructions for processing data and controlling program execution. However, in memory architecture, we have a very simple, just powerful instruction set consisting of 13 instructions. And as we mentioned previously in the other lecture, we know that each instruction for the memory consists of 16 bits, where the most significant 4 bit form the opcode, and the least significant 12 bit form the address of the for the instruction. So here the format of a memory instruction. We can see that the memory instruction consists of a 16 bits from 0 through 15. The most significant 4 bits from 12 through 15 make up the opcode that specify the instruction to be executed. On the other hand, the least significant 12 bits from 0 through 11 form an address which allow for a maximum of memory addresses of 2 power 12 subtract 1, because the address gonna start from 0. So here the table below show the fundamental memory instruction. The first instruction, that's the load instruction with the binary representation, that's a 0, 0, 0, 1. In hexadecimal, that's going to be 1. So the syntax for the load instruction, that's the load X. So basically, this instruction will load the contents of address X in the memory into the AC. The second memory instruction that the with the binary representation, that the 0, 0, 1, 0 in hexa, that's a 2, and that's a store X. So basically, this instruction will store the content of a AC to the memory at the address X. The next one is to have the binary representation, that's a 0, 0, 1, 1 in hexa, that's a 3, that's the add X. So basically, this instruction will add the content of the at the address X to the AC. So whatever currently in the AC will be added to the value of X, and the information gonna be stored into the AC. The next one have the binary representation of 0, 1, 0, 0. And in hexa, that's a 4, so that's corresponding to the instruction sub X. So basically, this instruction will subtract the content of the address X from the AC. So whatever in the AC right now will be subtracted by X, and the result gonna be stored back to the AC. The next one gonna be have the binary representation of 0, 1, 0, 1. So that in hexa gonna be 5. That's input. So basically, input a value from the keyboard into the AC. The next one is gonna be 0, 1, 1, 0. In hexa gonna be value of 6. That corresponds to the output instruction that basically output the value in the AC to the display. The next one have the binary representation of 0, 1, 1, 1. In hexa, that's 7. That's a halt that will terminate the current program. The next instruction have the binary representation of 1, 0, 0, 0. So corresponding to the hexa representation of 8. That's skip con instruction. So basically, this instruction will allow us to skip next instruction in the program upon condition on the value of the AC. We will show an example of how the skip instruction will be executed. The last instruction have the representation of in binary just as 1001. In hexa representation, that's going to be a value of 9. So that's corresponding to the instruction jump x. So basically, this instruction will load the value of x in the memory into the PC. That's the program counter. So here an example of Marie ISA instruction. So this have the bit pattern of 16 bit from 0 to 15. And this have the opcode of 0, 0, 0, 1. Okay, so the most significant 4 bit right here have the value of 0, 0, 0, 1. So this corresponds to the load instruction as we just discussed before. The second part of the instruction that's addressed right here, bit from 0 through 11. So you can see that this address corresponding to the value of 3. So basically this instruction saying that load the value found in the memory at the address 3 right here and copy that value into the AC. Here's another example of Marie ISA instruction. Basically, this instruction that is skip con instruction. So you can see that the opcode gonna have the pattern, the binary representation of 1, 0, 0, 0. So you can see that this is the opcode of the skip con instruction. We also can see that bit 10 and bit 11 here have the value of 1, 0. So this implies that the instruction immediately following this instruction in the program to be ignored if the value in the AC is greater than 0. Okay, so if we take the value of the AC and it's greater than 0, so the next instruction immediately following this instruction will be skipped. On the other hand, if the value in the AC is less than or equal to 0, this instruction to be ignored, and we just simply go on to the next instruction in the program.